Hello, Math Studies students, and welcome to your online lesson. Today will be a continuation of the previous lesson. We'll be continuing our discussion of systems of linear equations. But this time, instead of solving using either elimination or substitution, we'll be using graphing technology found on a graphing calculator. We'll know we're successful when we can efficiently solve systems of linear equations using our graphing calculator technology. So just a quick reminder that a linear equation is an equation that when graphed forms a line. We'll be dealing with systems of equations here today, also known as simultaneous equations or linear systems. And for those, we'll have two different equations where we graph them at the same time, and we want to find out where those lines intersect so that we have values, both x and y values, that work for both equations. The trick is for the equations that we'll be using on our calculator today, in order to get it into our graphing calculator so that we can graph the equations of the lines and therefore solve these linear equations, we first have to get the y variable by itself. Now, I wrote this in the notes here as the variable for the y-axis. And the reason I say that is because sometimes we have variables other than just x and y, and we might be using a's and b's as our variable, or p and q, or it might have a representation for like money, and so m is our y variable and time is our or t is our x variable. But the one that would be the y, that goes with the y-axis, that's the variable that we want to get by itself or isolated. And one common way to get the y variable by itself is to write it in slope-intercept form. We talked about that in the last video, but again, slope-intercept form, we often refer to it as y equals ax plus b or y equals mx plus b. But again, the most important part of this is simply getting y all by itself so that we can get it into our technology. All right, for our first example, what we're going to do is we're actually going to use the exact same equations that we used in the previous video. And what you'll notice about both of these equations is that y is already isolated. Y is by itself. And what I mean by itself is that we have y, and then we have an equal sign, and then we have some other stuff with our x variable. That's the important thing. So knowing that that is what we already have, we can type these directly into our calculator, and that's what I'll show you next. So I'll be using a TI-84 Plus calculator here. And this works the same as a TI-83 Plus calculator. Either of these get the job done. And the first thing we need to do is go to y equals. On our y equals, we want to actually type in our screen, or type in our equations into our screen. And so we have two equations already. We have this first one, which is essentially going to be our y sub 1, which they have listed over here on our calculator. And so since the y sub 1 is already written, all we have to do is write the 4x. So the 4 is just right off your number pad. The x is a special key right below the mode key here in the top left corner. And it says xt theta n, but an x appears because the smart calculator knows what we're dealing with, that we're dealing with y's and x's here. Regular plus sign, and then plus 6. I'm going to arrow down now to my y sub 2. And we will use our second equation essentially as our y sub 2. And you don't need to write y sub 2 here, but I'm just trying to match it up to show you that that is going to get typed in right here. The y sub 2, or the y value, is already there. And now I'm simply going to type 2. Again, my variable key, which is right below the mode, so 2x minus 2. And make sure you're using the minus sign and not the negative sign because the calculator treats them differently. All right, now what we're going to do is I'm going to hit the graph key, which is in the top right corner, the very top right corner of the calculator. And we can see two lines that are graphed here. And what we're trying to find out is where we have a point that is true or lies on both of these lines. And that point is going to occur when they intersect. Well, you can see here that I've got two lines. I'm going to trace over one of them here in blue that's coming down. And then I have another one that I'm going to trace over with green, and we can see that coming down. And they're going to intersect somewhere around here, but it's like almost off the screen. And so I need to change my view. Now, a lot of students will like to press the zoom key or zoom out or something like that, but I want to be more specific. You can see that I'm plenty far to the left, for this point of intersection, and I have plenty of room on the right. But what I don't have enough room is where the vertical screen ends. It's like happening right there. So I just want more down screen. I want more at the bottom of my screen. So what I'm going to do is go to Window, And the window shows my x min, which is the lowest x value or the furthest to the left. It shows my x max, which is the furthest to the right. The scale, or how often it's doing tallies for the x. And then it does the same thing for y's. Well, I want my bottom of my y, the bottom of my graph, to go down even lower. And so that's occurring here with the y min. And right now it goes down to -10. This is a standard screen. And if you weren't in this, actually, let me show you one other thing. If I go back to my graph and I hit zoom, and if I do zoom 6, what it'll do is it automatically go back to this 10 in every direction from the point of origin. So it goes, you know, an x min of -10, x max of +10, y min of -10. So if you ever have a window that's really weird, you don't need to reset your calculator. Again, you just go to the graph, you go to zoom, and then 6, and it'll make it the standard 10 in every direction sort of thing. But we want to adjust it, and again, we want the bottom y value to go lower. So, you know, maybe 15 would be enough, maybe 12, we're so close. I'm just going to go with a whole bunch. I'm going to do -20. And now I'm going to graph this. And you can see that our screen stretches down way more. In fact, the x-axis appears to be higher, but it's not that it's higher, it's just that we have so much more y. We have twice as much y down there as we do up here as far as our axis goes. So the important thing is, well, however we graph it, is that we can see where they intersect. And they are intersecting right about here. And we're going to let the calculator tell us where that is. Now, again, some students might be tempted to hit the trace button, which allows you to like sort of arrow along and it'll tell you different values. But it's giving you rounded values, and it's not what we're looking for, because even as I go towards where it intersects, it doesn't exactly give me a nice whole number. And we solved this exact pair of equations last class and we got nice whole numbers, so I can't find it there. So anytime you're tempted to hit the trace button, what you really should be hitting is second and then trace, which is actually a calculate button. And then we have a list of options here. We'll use many of these throughout this course, but we are interested in choice 5, where they intersect. And so you can either arrow down and hit enter for intersect, or you can just hit the 5 key on the number pad. And now a question has come up. It is asking us first curve, and what that means is first equation. A lot of equations graph curves. This is actually a line, but it's saying click on your first line. And as I arrow over, you'll notice that cursor that's moving is on this top line. And the top line must have just been the one that I typed in first. I only typed in 2 lines. So when it says first curve, the only thing you have to do is just hit enter. Then it's the second curve, and you will notice that the cursor jumped down to the second line. So it's already automatically going to the second equation, and I only want to use 2 equations, so I'm just going to hit enter again, saying yes. Yes, I liked that first equation, and yes, I like that second equation, and of course it did, because I only put 2 equations in. And now it says guess. Now the calculator might say, oh, I bet it's a smart IB student who's working on this problem, and they know exactly what the guess is, so I'm going to maybe think about their opinion. No, that's not what the calculator is thinking. The calculator is just concerned, are you talking about this point over here where they intersect, which is this spot right here? Well, on these particular lines, they only intersect at exactly 1 point. So it does not matter where you guess. It does not matter where you guess. The only time it would matter where you guess if we had a more complicated function, you know, something like that, and then there were many points of intersection, like 1, 2, 3, then it would ask you to guess, meaning move your cursor closest to the one that you're interested in, and then it would give you the exact coordinates of that one. But since our 2 lines only intersect at 1 point, we don't really care about our guess. We can just hit enter anywhere, and that will get the job done. So I'm hitting enter, and it says intersection at -4, 10. So that would be the answer to our problem, -4, -10. X value is -4, y is -10, and that's the point where they intersect, a point that lies on both lines, a point that makes both equations true. Now let me run through those steps one more time. So we went to y equals, we typed in our equations, then we went to graph. I adjusted the window by hitting the window key and extending my y minimum. I can go back to the graph, and now I want to find out where they intersect, so I hit second, and then trace. Not trace, but second and trace, which is calculate. It's going to actually find that value for us, calculate it. I go to the choice 5, which is intersect. It says first curve, I hit enter. It says second curve, I hit enter. It says guess, I hit enter, and voila, it's giving me the answer of -4, -10. Moving on to example 2. Same example we looked at in the last video, we did elimination previously, and the reason for that is our equations matched up their variables, but they did not have any variable isolated. Well, in order to graph these in our calculator, we do have to isolate these variables first. So this is not nearly as ideal of a candidate for us to do this type of work, but we can get our variable by itself. And again, we're looking to get y by itself. I'm going to start with the second equation here, just because it has some room below it for me to work. So I'm going to get rid of this x. It's positive x. To move it to the other side, I subtract x from both sides. So now I have negative 6y equals 6 minus x. Now technically, to be in slope-intercept form, I should put the x first, but I'm really just interested in getting y by itself. So I'm going to divide and get y equals 6 minus x all over negative 6. Now I could simplify this and get 6 divided by negative 6, which is negative 1, and then I could have negative x over negative 6, or positive 16x, but I'm just going to leave it like that, type it in my calculator, because I did the thing I really needed to do, which was get y by itself. Now I'm going to do the same thing with my other equation. I had 2x plus 2y equals 5. To get y by itself, I'm going to subtract the 2x from both sides. I have 2y equals 5 minus 2x, and then I'm going to divide both sides by 2. So I have y equals 5 minus 2x all over 2. All right, now I need to get that into my calculator. So I go to my y equals. I'm going to clear out this first equation. Again, I use the clear button, which is right below the down cursor arrow. And I'll put the blue one in first. So we had a group of things. This group is the 6 minus x all divided by the negative 6. So I need to tell the calculator it was a group using parentheses. So I have 6 minus x, close parenthesis, divided by, and now I have to make sure I use the negative sign and the 6. You could also put that in parentheses. A lot of times I would, just because there's a negative and I want to group it with it, but that should be just fine. And now I'm going to clear out my second equation and type in, again, we have a group happening here. This time it's the 5 minus the 2x. So I need to tell the calculator that's all in the numerator. It's a group. So I have 5 minus 2x. Again, that x key is right below mode, or our variable key. And then we're dividing all of that by 2. All right, now I'm going to go to graph. And before I really do too much, I'm going to go back to zoom, and I'm going to do zoom 6, which is standard. So I get back to that 10 by 10, or 10 in every direction window. I guess it's technically 20, because we have negative 10 and positive 10 as our min and max. But and I like that window. It's good because I can sort of see where the intersection is happening. And as long as I can see it, the calculator can calculate it. So we're doing the exact same steps that we did before. I'm going to press second and trace, which is going to calculate for me. I want to calculate the intersection, which is choice 5. It says first curve. Well, again, I only put in 2 equations, so I can hit enter right away. Then it says second curve. You'll notice that the little flashing cursor jumped to the second equation. I can hit enter right away. Now it says guess. You don't need to move your cursor because there's only one intersection point shown on the screen. So I hit enter again, and it tells me that the intersection is happening as an x value of 3 and a y value of negative 0.5, or I could write that as negative 1/2. I can write that as an ordered pair, and I have solved 2 systems of equations using the graphical technology. All right. A reminder that you can find additional problems for this section in section 4I from our orange textbook, and hopefully these steps will help us to efficiently solve some linear equations using our graphing technology. Till next time.